Hey, Chris, why do we always tell learners to start with OpenAI?
Well, because it's performant and it's easy to use.
But Hugging Face,
Yeah, definitely dope. Yes, absolutely.
but is it as performant and easy to use as OpenAI?
Well, they're kind of built for two different, purposes. They're solving two different problems. Hugging Face does have the best open source models available, and so it's performant in terms of ease of use. Though it definitely could use some work.
So getting started quickly has kind of been a bottleneck for using open source models.
I would say that's generally true.
Okay. Well, I heard Gradient built a dev tool that apparently solves this problem. Does it really work the way we thought it would?
It does exactly what it says on the tin, Greg. Yeah,
That's super
absolutely.
hype. That is super hype, dude. Are you ready to show everybody today what we learned and how it works?
Yes.
All right, man. Let's get into it. Hey, everyone. I'm Greg, and I'm the founder and CEO of AI Makerspace. Thanks for taking the time to join us today. What you'll learn from this event is how to host and fine-tune open source models with Gradient, and how to use these open source models to build a Retrieval Augmented Generation, or RAG system. We also have a special guest today, Mark Huang, co-founder and chief architect of Gradient, who will be joining us for the Q&A portion of today's event. If you have questions, throw them in the Slido in the YouTube description box right now, or upvote your faves. And of course, the LLM wizard and CTO at AI Makerspace, Chris, will be back on stage to lead code demos real soon. So with that, we're going to go ahead and get right into it. We're going to talk about the AI engineering Lego blocks that we are using to build these days and how this space is evolving. That's sort of the core of today's event. We're going to talk about how to do fine tuning. We're going to see it. We're going to talk a little bit about RAG systems and some of the latest things that you want to keep in mind as you're building with LangChain. And then, of course, we'll do Q&A, which we should have plenty of time for. And we've got some great people to answer the toughest questions that you can throw at us. Since we're doing an event with Gradient, we wanted to sort of give it a bit of a gradient flavor today. So consider the all-important question. Do I need to learn gradient descent to build LLM applications? This has been discussed in many circles for years, going on a solid decade, for me at least, being in the space. When you ask GPT-4 this question, it says that's a good question. You do not need to know gradient descent. Many tools like PyTorch and TensorFlow and Hugging Face, they actually take care of this for you. So under the hood, you don't really need to understand how it works to drive the car. But there are other perspectives on this. Like, for instance, Andrew Ng and Deep Learning put out a great batch article last year on the top 6 essential algorithms that you need to know to get started building with machine learning and AI. And from linear regression to gradient descent to neural networks, it's hard to disagree that a foundational knowledge of these algorithms is important, at least an intuitive understanding. So we wanted to find out, by taking a look at this new tool and addressing this age-old problem, what will the research tell us? If we build a RAG system that uses references and is connected to all of the papers that are being written on gradient descent, what will the researchers tell us? Well, we're going to find out today. And in order to sort of think about some of the new ways that we can engage with open source models, let's think about how we engage with closed source models, like from OpenAI. Of course, this is top of mind for everybody after Dev Day this week. Let's consider that OpenAI can be used directly through ChatGPT, but also as a developer. And when you tap into the GPT models as a developer, you simply write your prompt, and then you call the chat completions model. This is something that we've talked about previously in events like Beyond ChatGPT. if you're looking for more details. We can also then receive a response. As a developer, this is going to look like a response object that has everything from the actual content of the response to the number of tokens used and much more. But what happens is that open source models are a little bit harder than this tapping into the API and getting a response. We've done an event on how to do RAG systems with open source previously, but the cliff notes are these. Instead of just tapping into the API and calling it, you need to potentially download all the model weights. You need to load the tokenizer. If you're using quantization, you need to configure those libraries. If you're using a chat model that tends to be verbose, you need to define stopping criteria. And finally, you, of course, need to build the Hugging Face pipeline. And so while, on the back of OpenAI's Dev Day this week, we're seeing startup founders, some of them get a little bit worried that things aren't getting easier for them. Things are getting easier for developers and that's what we've really tried to investigate here. And we're going to try to highlight for you exactly how they help out. So let's consider the framework that we and many others are sort of using as a lens for building complex and useful LLM applications. You prompt as far as you can. Then if you have some data that you think can augment this system, you leverage it in terms of a RAG or question answering system. And you also investigate the fine-tuning of models, both embedding models and LLMs in the context of question answering or RAG systems. We're going to focus first today on fine-tuning, because fine-tuning open source models is easier than ever now. And that's one of the things we want to showcase. So today, to build our sort of fine-tuned LLM-powered RAG system with open source models, we're going to go through a few steps. We're going to show you how to leverage Gradient. We're going to host a chat model on Gradient. We're going to instruct-tune that chat model directly, and we're going to host an embeddings model. And then we're going to essentially do what we could do with the OpenAI GPT models and Ada embeddings within our RAG system. We're going to tap into them directly via API. So we're going to focus on these first three steps first: the chat model hosting and the instruct-tuning. Now, if you don't remember what instruct-tuning is, or you never quite dug in, we're going to give you some cliff notes here and some resources to learn a bit more. But for today, what you really need to understand is that instruction tuning is just one type of fine-tuning. There are at least a handful of types of fine-tuning that we can focus on, and we look forward to bringing content to you across the fine-tuning spectrum soon. But today, if you sort of think about how these generative pre-trained models are working at a fundamental level, they were trained using unsupervised pre-training on very large amounts of data, transformer architectures, and then they were fine-tuned to be more task specific. What we saw in the evolution of these models, if you consider OpenAI, the evolution of GPT to GPT-2 to GPT-3 to then instruct GPT, what became important after we realized we could do very, very good next word prediction and crush benchmarks was alignment. And alignment is done in kind of two ways. One, we can sort of fine-tune our models to follow instructions better. That's called instruction tuning or instruct tuning. And two, we can use reinforcement learning with human feedback. If we focus on this idea of instruction tuning, and we've got some comment for you to go deeper on, got some content for you to go deeper on this if it's of interest to you as well, then we can kind of connect it directly back to what we're doing when we start building LLM applications with prompting and prompt engineering. The number one most important thing when you're prompting the LLM is to give it really, really specific instructions. Because as humans building with these AI systems, we want to be able to give them exact instructions, and we want to get repeatable, predictable outputs that are reliable, aligned with us, that are safe, that are not going to have a negative impact on our users or our customers or any internal stakeholders. And so when we go and we do instruction tuning today, you'll see how easy it is. Essentially what we do is we take prompt response pairs. Oftentimes these data sets are created by humans to make sure they're totally aligned with us. And we then fine tune the model by optimizing and minimizing cross entropy loss. The data set we're going to use today is the Mosaic ML Instruct v3 data set. And you can see an example of what this looks like here. The exact syntax that we'll use for fine tuning is also the syntax included in each prompt. Below is an instruction that describes a task. Write a response that appropriately completes the request. Instruction. I'm getting into music history and want to listen to authentic analog music from the 80s. Which of the following should I try? Well, if you're trying to get into analog, maybe vinyl, cassette, and CD. Try those first. So what we're going to do is we're going to see exactly how this plays out in code and how we can leverage Gradient's tool as we pick up Llama 2 as a base chat model that has not yet been instruction tuned, and we instruction tune it. So this is what we're going to see Chris, the LLM wizard, present to us in this first demo of the day. Chris, over to you.
Thank you, Greg. Okay, so we're going to dive right in here. The basic idea behind Gradient is that it is an incredible tool for, basically hitting a model, fine-tuning or, training a model, and then leveraging that in your application. It's very easy to do this whole process, and it's very straightforward to get going. And for me, one of the best parts, on-demand pricing. So you pay by token, which is super handy. So we're going to use a few tools today. We're going to use Llama Index. Llama Index built a really convenient wrapper for fine-tuning with Gradient. It kind of abstracts away some of the loops that you might need to write otherwise. We're going to use LangChain to leverage and power our Retrieval Augmented Generation application. And then, of course, the star of the show, Gradient. We're going to use Gradient to select our base model, fine-tune, and on. First thing we need to do is sign up for Gradient. I mean, it should come as no surprise. You'll need to sign up. You receive some number of credits when you sign up. And they were enough to cover the cost for what I did. So you shouldn't run into any additional costs. Once you've signed up, you'll need to create a workspace. I'll go ahead and show you what this UI looks like. It's fairly straightforward. To create a new workspace, you click the Create New Workspace button and then create a new workspace. You might want to add billing if you're going to continue to use the tool or you want access to additional credits or tokens. And then once we have our workspace generated, we'll want to take note of this workspace ID. We'll also need to create an access token, which we can do by clicking on our access token here and then generating a new access token. We'll input our password and generate a new access token. Make sure that you store it somewhere safe so that you have it for the collab demo. And then there you go. So very simple to get up and running with Gradient. Once we are up and running, we're going to move on to some different pre-work that we have to do. So the tool we're going to use today to fine-tune with Gradient is going to be a Llama Index wrapper. Now that's going to expect that our data is in a specific format, which is a JSON-L file. And we need to have very specific objects in that JSON-L file. So we're going to do that in the next few cells here. We're going to train with this Mosaic Instruct v3 dataset. It's an aggregate dataset of a number of different instruct datasets, as well as some, helpful and harmful datasets. The idea here is that it's a very diverse instruct data set that should hopefully allow our model to follow instructions just a little bit better than the base Llama 2.7b chat model, which is conversationally tuned, but not fully instruction tuned. We're gonna grab a bunch of dependencies here, pip install them, the routine, and then we will, of course, use our access token and workspace ID, which we will carry through in our environment, and that will kind of power the rest of the demo. It's a very, very, very good, tool. It works right out of the box, and you'll see I had no hiccups at all getting it running. So we're going to grab our data sets dependency here, and then we're going to format our data set. Now, the first thing we need to do is we need to get the data set from Hugging Face. So we're going to use our load data set function to do that, and that's going to pull the whole thing down. We can look at it, see there's a ton of examples in our train split. We have our prompt response and source. Now, when we send our inputs to Gradient, they're going to be sent through that Llama index wrapper, which is going to expect them in a specific format. So we need to make sure that we modify our data set to contain that information so we can leverage the Llama index fine-tuning engine. So we're going to do that next by formatting our prompt. We're going to use this prompt template today. Now, we're using Llama 7b chat, which does have its own kind of token sequence, which is fine. But the Llama index team found better results when they use kind of this classic prompt template. So that's why you're not seeing the INS tokens here. The general idea, though, is that we want to create a prompt which is formatted exactly like this for every single prompt and response pair in our data set. So we'll use this create prompt function, which is very explicitly written to show us that we're going to have our full prompt. We're going to add our beginning of sequence token, add our instruction header, add our system message, which is a below is an instruction that describes a task, write a response that appropriately completes that request, classic system message. We're going to add our user message. We're going to add a response header, and then we're going to add our response and an end of sequence token. And that's going to go into our inputs column in our data frame or our data set. We can look and see how it works by calling it on a random sample of our data set. It's not really random, it's just the second one, but still. We can see here that we have our beginning of sequence, instruction header, instruction, response header, response, end of sequence token, just as we would hope. All we have to do now is map this bad boy across our whole data set. We can look and see now that we have a new column called inputs in our data set. And if we look at that same example now, at the inputs column, we'll see it's formatted in precisely the same way. Everything worked. We're very happy. We're going to do some naive filtering. The reason why is that Gradient's API is currently limited to an input context of 2048 during fine-tuning for the Llama 7b chat model. So all we're going to do here is just, if these sequences are too long, we'll just chop them out. Again, this is more of a toy example, just meant to show you how Gradient's system works, how effective it is. So when you extend this to your own use case, be aware that you will be facing that limit, but you should probably use something a little bit better than just anything less than 2,000 characters and we're done. All that does is reduce your data set by a measly 20,000 rows. We're not going to use even half of these, so it's not a big worry for this application. But the idea is, be mindful of the limitations of the different models you can use through Gradient. And then we'll just save it to JSON-L using the handy dandy toJSON method of our data set. Now we're good to go on instruct-tuning this model. Now, that was all just preparing the model. All we have to do now, or preparing the data set, sorry, all we have to do now is set up our base model and then fine-tune it. Llama Index has two different ways that we can load our model. We can load it as a base model LLM. This is going to let us interact with the base Llama 2.7b chat right out of the box. You can see that we have our max tokens parameter. And basically, this just acts as an LLM object. So you can just, if all you wanted to do is hit Llama 2.7b chat, this is all we need to do in Llama Index. However, we're going to instead use their gradient fine-tune engine, which is going to let us fine-tune the gradient endpoint that we choose with the data set that we created. Now, you'll notice that we still pass that base model slug, which is found up here. This is our Llama 2.7b chat, because our base model will still be Llama 2.7b chat. We're going to name our fine-tuning job instruct-tune, though it could be named whatever you like. Probably should be named less generically, to be honest with you. And then we're going to point to our data set, which is that JSON-L file. Verbose is true. That's it. Let's us see. Max steps. This is how many steps we're going to train for. And batch size is 4. That's how many samples we're going to send at once to the fine-tuning endpoint. So if we look at the fine-tuned model endpoint here, you'll notice that we have this ability to add objects, and the objects have inputs. And so basically, we're going to send 4 of these at a time, and then we'll ping it again, and then again, and then again. The idea here is that each step will send 4 total rows of our data set to gradient for fine-tuning, and then we'll repeat that process 100 times. Now, you'll notice we're using Llama 2.7b chat. What other models could we use? Well, right now, they have Bloom 560, and then they have a new Airmay 2 fine-tune. This is the uncensored instruction fine-tuning of the Llama 2 13b model. So these are the different models that they currently have access to in terms of fine-tuning, though I expect more will come along the way. So this is it. This is basically all we need to do. The only thing left to do now is call train. What we're going to do is just loop through our epoch. In this case, we're just going to train for 1 epoch. So we're only going to do this loop once. We are going to fine-tune at each step. You'll notice that we have the fine-tuning step be all the way to 100. You can see the loss for each of these steps, and it's coming up in increments of 4 as we're sending 4 rows at a time, essentially, to our fine-tuning endpoint. And that is it. That is how easy it is to fine-tune with gradient. This is the whole process. So it's not a lot. It's very good. And at the end of this, we have a addressable model that we can use to power our RAG application. And if you thought that was straightforward, well, to access the base embedding model with gradient is even more straightforward. We're going to switch to LangChain as we prepare to use our RAG system. You can see all we have to do is call our gradient embeddings with our BGE large model, and we're done. We now have an embedding model that we can access on gradients through gradient. You'll notice that right now, BGE large is the only model that they currently support, as this embeddings model feature is currently in beta. But I imagine you can expect more to come. And I believe as well, you can expect some fine tuning for embeddings to come, once that feature is out of beta. So very powerful, very incredible tool, and really simplifies getting your base model up, hosted, and ready to rock. With this, we're ready to move on to the next step. But first, we'll talk to Greg for a little bit to learn more about RAG.
Yeah, thanks, Chris. Very cool. So we all set up. We've got our model that's basically just an endpoint. Now we can hit it. Now, what are we going to build with this? Well, let's go back to our framework of building LLM applications. Let's attack this idea of question answering, or essentially RAG is nothing but question answering over documents in most cases. What's the point of RAG again, for those of you that maybe aren't as familiar? Well, the big issue with LLMs is that they'll lie to you. They'll just sound really confident about something and it just won't be true. So those false confident responses, those are a real big problem. How do we get around this? Well, how do we get around this in real life? We get around this by making sure that everything that we say can be fact checked. Everything has a source, everything has a reference. This is very important in journalism and just in conversations that are really trying to get to the bottom of something. Is there a reference? Or are you just pontificating? This is where retrieval comes in. Retrieval is all about finding references from your documents, from your private data, or from any other data that you find worthy of providing reference material. The augmentation piece in RAG is simply taking those references and adding them to your prompt straight into the context window. The generation improves with more references and with more reference material stuffed into the prompt. So this is RAG. What does it look like? Well, let's take a look at a system overview. That should look pretty familiar to some of you that have been following our content. We take a question, we feed it to an embedding model. That embedding model takes our tokenized text and turns it into a dense vector representation. That dense vector representation captures the semantic meaning of our query, and it looks for similar information contained in our vector database where we store all of our documents as dense vectors. Once it returns those similar dense vectors, we can use them. Where are we going to use them? Well, we're going to use them in the prompt template that we set up. That's going to eventually contain everything we need to go into our LLM model. We're going to use a system level prompt, something like use the provided context to answer the user's query. You may not answer the user's query unless there is a specific context, unless there is specific context in the following text. If you do not know the answer or cannot answer, please respond with I don't know. So we set this up. Then we go ahead and we retrieve our references, 1, 2, 3, 4, N references. For a simple RAG system, we line them up, we stuff them into the LLM, we get our answer out. What we're focusing on here is we're focusing on how we can host these models from Hugging Face very simply, very easily, very straightforwardly. The rest of the pieces of this system, let's consider what we're using in terms of tooling for each of them. The glue that holds all of this together, we're going to use LangChain. The fine-tuning wrapper, as we saw, we actually used Llama Index. For our vector store, we're going to use Facebook AI Similarity Search, or FACE. And for our reference material, for our vector store, for our documents, we're going to look in archive and find the top gradient descent papers. What does this look like? Well, you could kind of imagine all this is being held together with the glue that LangChain provides. LangChain also has a nice integration to archive, allowing us to build our face vector store very quickly and easily. And as we heard from Chris, we're going to use the BGE base model for our embeddings, and we're going to use Llama 2 7B chat for our chat model, which we've already instruct-tuned. So all together, we've got something that looks like this. Llama 2, fine-tuned with Llama Index wrapper. We've got our Hugging Face sentence embeddings model, BGE large, and we're ready to build our RAG system. So just so you understand the flow here, let's call it the meta gradient flow. We're going to search for the top papers on gradient descent. We're going to turn those papers to embeddings, put those in our face vector store. That's going to allow us to ask questions against our content and return answers that are not hallucinations. They are not confabulations. They are fact checkable. One more thing. We've done some events on LangChain before, but one of the things that you'll see today that maybe you haven't seen is LangChain expression language. This new way of building with chains is declarative, and I mean, is awfully elegant, is it not? I mean, this is just sort of a beautiful line of code. And it really does a great job at handling all of the finicky bits that LangChain used to require a little bit more work to get right, like async, like streaming, parallelism, and it really integrates well also with LangSmith, a production level tool still in beta. All right, we're ready to build and bring this all together for the day. We've got our hosted instruct-tuned LLM. We've got our hosted embedding model, and we're ready to build our RAG with LangChain. Chris, we'll show them how it's done.
Oh, yeah. Okay, so we've got everything hosted on Gradient. Gradient's doing basically all of the work for us in terms of our LLM and our embeddings model. And, we haven't had to really lift a finger, which is just by itself, by the way, an invaluable tool in a tool belt. So first thing we're going to do is use the Python SDK just to see, what models we have. You'll notice that we're not only looking at the base models, we do want to look at our adapters, and we're printing the adapter ID and name for every adapter that we find. You'll notice that I've named them all instruct-tune very helpfully, not so. The idea is you can use this to determine which model you actually want or want to look at. We care about this last one because it's the one that we did the full run on. And you can see here that we have the LangChain loader for Gradient. Now, this is it. You simply pass your model ID, and you can pass some additional kwargs if you'd like. Here we're limiting the generated tokens to 128. And that's it. LangChain and Gradient have an excellent integration, so it makes it very simple to get this running. We're going to create a prompt. That prompt is just going to be exactly the prompt we use to train the model. And then we're going to have this prompt template for LangChain. We're going to build an LLM chain the old way, where we have this LLM chain. We pass in our prompt in our LLM. This is going to chain our prompt into our LLM. That's great. And we're going to ask a question like, what is the opposite of gradient descent? We run our chain and we get the response. The opposite of gradient descent is called stochastic gradient descent. I am not satisfied with that answer. It is maybe in some ways it's true, but in other ways it's probably not, right? So the idea is we need some more context to ground this answer so that it can be more appropriately answered, or at least more satisfyingly answered. But you'll notice, this is powered by that endpoint from Gradient already, right? This is all of the work of getting it hosted was done. All we did was hit this endpoint and we got our response back with just those two environment variables. So super handy tool. Then we're going to extend this template to a RAG template, which is going to ask for context and a question. We're going to call that our RAG prompt. We're going to chain our RAG prompt into the LLM now using the LCL. You'll notice that all we have to do is chain our prompt into our LLM. This pipe operator, you can basically think of it as we are piping our RAG prompt into our LLM, right? So this is a very, very great way to use LangChain. Really simplifies things. It also handles a bunch of stuff behind the scenes that's very powerful. When we're talking about the question now, we can ask what's the opposite of gradient descent, and we're going to provide context, and that context is going to be just the Wikipedia copy and paste about gradient descent, and we get the response steepest ascent. I mean, this is a much more satisfying answer. And in some ways it's correct, right? The opposite of gradient descent is gradient ascent. There you go. When we're asking a question about, say, the maximum airspeed velocity of an unladen swallow, which, the context has no reference to swallow, it's all about gradient descent, we get the answer we want, which is, I don't know. So this is the idea that we're grounding our answers in some kind of reality. And because of that, they answer questions better. Then we're good to set up the RAG chain. We're going to use LangChain for this, and we are going to use the archive loader. First thing we'll do is load our documents from the archive loader. We're going to load 5 papers about gradient descent from archive. We're going to chunk those papers or split those papers into 1250 size chunks. This is so we don't exceed the inference context window of our newly trained model. Now, by the way, the inference context window is the full context window we'd expect from Llama Index. So we can put more context in there than we were able to during training, which is great. All we have to do is split all of our documents up, and we're good to go. We're going to create a face vector store from documents, and we're going to use our embeddings model that we set up earlier through Gradient. Now, the only limitation right now, and again, this is a beta feature, so you can expect these kinds of things to potentially change. The only limitation right now is that it's only accepting 100 items at a time. So we have to batch our documents into sets of 100, which we're just doing naively because there's only 200 documents. But the idea is that we send 100 documents at a time. They're embedded by the gradient embeddings model, which is BGE large, hosted by them. And then we shove them into our face vector store. Once we have our face vector store, we're going to set up a retriever. And once we have a retriever, we're good to create a RAG chain. You'll notice that we have the same LCL syntax here. We're going to go ahead and create our first object or input object, which is going to be grabbing context from our retriever. We're going to pass our question through to the next step. So the idea is we have some input, which relies on this retriever object. So that's what's going to take our invocation. Then we are going to pass our question through along with the retrieved context to our RAG prompt. We're going to format that RAG prompt, and then we are going to pipe it into our LLM. And then we are going to pipe our LLM's output into a string output parser just so it looks beautiful. Then we can ask questions like, what is gradient descent? And we get a good answer about what gradient descent is. Is it mandatory to learn gradient descent in detail to build large language model applications? Our fine-tuned Llama chat model says, no, it is not mandatory. And then what do I need to learn about gradient descent, to build large language model applications? And basically just learn the basics, right? Learn what it is, its applications, and some of its limitations. The idea here is that we're able to create a RAG system that is using fully open source models and is hosted on Gradient, and we are paying per token for these outputs, which is incredible. And so I'm going to pass it back to Greg at this point, now that we've seen this thing work.
Awesome, Chris. All right, so that's how we can get ready to rock and roll with open source. Super streamlined, super quick. These models are easier to use than ever. You can access them through API. You can do fine tuning through API. You can do everything that you can do through OpenAI. And these RAG systems are also as easy as they've ever been to build with truly open AI tools. Fine tunings for gradient, fine tuning embeddings is currently in beta. So watch that space. And then, of course, as always, we're going to keep watching for new tools that can streamline our workflows as AI engineers, as aspiring AI engineers. Definitely let us know if there's any tools that you'd love us to investigate and try to get to the bottom of. But with that, I'm going to go ahead and throw this slide up. This is the QR code for Slido. We'd love for you to jump in there, upvote the top questions that you want to see answered. And I'd like to invite Mark and Chris onto the stage now. We're going to get going with Q&A. We've got plenty of time, so don't be shy about your questions. But I'd like to kick this off with one of the questions that really kind of ties a bow around this entire event. Do we actually need to know gradient descent to build with LLMs? What do you guys think? Chris, what do you think first, man?
Definitely not. I mean, you should be aware of kind of how these models are trained or or have an awareness. But in order to build applications with them, I mean, it's not strictly necessary. There's so many levels of abstraction at this point. There's so many ways that we don't really need to get into the nitty gritty details of the actual model that, for the most part, you're good to go without really getting that bottom up understanding. Obviously, that's going to change if you need to fine tune or train yourself, but for the most part, you're chilling.
Mark, what do you think?
I think I learned it so everybody doesn't have to, in a way. I think it's it's interesting to build some intuition, but with these models being just basically compressing all of human knowledge inside of them, you really just want to look at that loss curve go down. That's usually my tip for people when they ask me, like, how do I know if the model's learning? Like, just check your loss curve and make sure it's just kind of going down.
Nice. Yeah, I also agree. Building a little intuition is probably helpful. And, we're dealing with a similar thing as we investigate the world of transformers in another course. How much code, how much intuition at the conceptual level. It's tough to really navigate, but it doesn't hurt to make sure you hit both sides at least a little bit. The next most obvious question of the week we've got, and it's the most upvoted question, is, so OpenAI Dev Day was obviously massive on Monday, and everybody's talking about it. How does this impact the world of RAGs and also of fine-tuning? Mark, I want to start with you on this.
Well, I think it's kind of interesting because it's awesome to see someone keep on raising the bar. So, OpenAI, they are developing and they are on the forefront of the most powerful models and making it easier for everybody. So then, what goes through my mind is, how do I start creating the higher levels of like convenience and bringing together all of these tools to help other people build better? So, I actually don't really view ourselves as being the replacement for them. Like, we're kind of a complementary solution, because I think that you got to play with the open source models and developments in order to understand how to like roadmap, your architecture in the future.
Yeah. And Chris, before I go over to you, I did notice that they had a little like upload your doc real quick sort of UI that was almost like RAG without even knowing you were doing RAG. Like, how do you think all the announcements taken together sort of impact the world of RAGs and fine tuning? Big question.
I mean, they really don't significantly impact the worlds of RAGs and fine tuning. I mean, it's dope that you can do simple RAG with OpenAI's tools. It's dope that you can, it kind of makes it more accessible to people who are familiar with like the OpenAI suite of tools, but maybe haven't delved any deeper. But in terms of like the amount of work that needs to be done on both the retrieval pipeline side of things and even how it interacts with the LLM, I don't think this is going to be like a death blow to RAG or anything like that. It's just it's a great way to get access to this kind of tooling quicker and in a way that people are familiar with. In terms of fine tuning, I think Mark already addressed that very well.
Yeah. Well, Mert loves your hot take, Chris. Let's go on to the next question, which is this one's for you, Mark. What open source models do you plan to add next to Gradient? And how do you go about picking the most important models to host on your platform?
Oh, you're really pushing me there on that question, because I'm, very much wanting to get Mistral on the platform, kind of ASAP, knowing that they're gonna probably release larger model sizes. So they gave you a little taster on that. But we already have on the roadmap supporting multimodal models, and that's kind of been under the covers for a little bit. But I think it's sort of time that we can introduce that concept to everyone and actually just open up the entire world to making it easy to compose all of these models together into like one system.
Nice. You heard it here first. Multimodal coming soon from Gradient. Super cool. Talking a little bit more about R&D happening in this sort of space of fine tuning. What are you guys seeing? And maybe I'll start with Mark on this one too. What are you seeing like in terms of research and development that's most interesting to you that you're spending time thinking, does this belong on my roadmap? What are you paying attention to right now, Mark?
I think usually when I think about fine tuning, I think about two things, like the data and then how the loss function is working or like being propagated into the model. So I know, I said you don't need to know gradient descent, but from an R&D perspective, I do need to know it. So the first thing is like, how do you use techniques to kind of probe the knowledge that's already in the base model? Because none of the data sets are actually open source, even though the weights are. So net new data actually helps it a lot. And then knowing like the mixture of the corpus helps a lot for like retaining the knowledge as you train it more. So then that's one side of things, so that I just know what data I need to grab and the types of things I want it to do. And then the second part is, you talked about alignment. ROHF kind of dominates the world right now in terms of like alignment strategies, as well as ROAIF, which is like using another model to like align itself. But there's direct preference optimization too, and we're kind of moving ahead on like figuring out when you don't need as many labels to make the model more aligned to like what you want it to do. So those are kind of the two main areas that I'm always sort of searching and in reading the papers on.
Nice. What papers are you reading, Wiz?
Well, I'm going to answer this question from a slightly different perspective because I feel like it's the nature of the event. I think from a R&D perspective, if you just want to build with these tools, you don't need to focus on anything. Mark's focusing on it. Gradient's focusing on it, right? This is the idea that, you don't need to get down into the weeds for the most part. If you do, there's all kinds of fun, papers about how to fine tune more efficiently on smaller hardware or more quickly, or, with less data or different kinds of training. So you can do, curriculum-based training to get better at, there's an infinite space of things you can do. But I think from answering it from the perspective of just the builder, I think the best thing you can do is follow tools like Gradient and others that are going to help alleviate that part of the stack from your worries.
Work at the right level of abstraction, do the development, don't focus so much on the research. Yeah. Okay, another one. We're getting some upvotes here. Definitely keep the upvotes coming because we got a lot of one vote questions here. Are there any image generation models coming before multimodal that, I guess for Mark, are you paying attention to this specifically for image gen or straight to multimodal for you guys?
I think we go back and forth with that all the time because it's sort of, one is pushing the other and we're learning. So I tend to think that actually, and this is kind of a tangent, like the real innovation behind everything is just like applying self-supervised learning to everything. Like that was the thing that people took from convolutional neural networks. In terms of like the image generation models, yeah, we're considering some, but the main thing is like the use cases first. So like the multimodal aspect of things actually unlocks a lot more use cases, and we want to stick to the feedback we're getting from like a lot of our customers on that side of things. But don't be surprised if we do end up dropping a text to image fairly soon, like, or maybe using like one of the projections for like the Lava model, because like you can fine tune and then enhance a base model into being like an image generation and annotation one. So just look out for announcements that we'll probably be posting really soon on that.
Nice. Yeah, just my 2 cents from a business leadership perspective, it's tough to sort of find enough customers that really, really care about image gen versus LLMs. And that's kind of what we've seen even with learners. Most people want to build with LLMs when we've offered both. Most people go to the LLM Zoom breakout room. When we talk to customers, nobody's really sure how to make money with the image models, although multimodal is very sort of philosophically and interesting and attractive from a learner perspective in many, many ways. Chris, you have any thoughts on this image gen and paying attention to it today?
I mean, yeah, like, keep up on it, see what's happening, see what the latest and greatest is. I think what Mark said is the more appropriate take, which is like, we want to instead leverage these models that are kind of good at everything and use them to better understand and work on image related data. It's cool,
Yeah.
but not my use case. So
Yeah. All right, we got a great question that's coming up in the chat here, and I want to start with Mark on this one. It's kind of a gimme here for companies trying to leverage fine tuning in-house for building with LLMs, including RAG systems. Should they stop doing that and simply use OpenAI or Gradient instead? What do you think, Mark?
I will either recuse myself or give my biased opinion. But my biased opinion is like, you don't want to be building these things in house. I have built distributed systems in the past, and then once you build a distributed system, everyone I know kind of comes back and it's just like, oh man, geez, I don't ever want to build another one, just because it's always tough, and there are always considerations on scaling. And my belief is like, what is the velocity at which you're trying to ship at? If it is, if your core competency isn't trying to be like a fine-tuning platform or an AI like research company, then you should be building product and leverage the tools that you can do that with, because even having to maintain the entire suite of AI tools themselves, like the burden is sort of on us as Gradient. If the new model comes out and is significantly better, we got to hurry up and support that, deprecate previous things, figure out how to scale them up. It isn't as simple as just pointing to Hugging Face model path. There's just so many optimizations that go into like serving these models too.
Love it.
yeah, this is the build versus buy discussion, right? And I mean, if you're an early stage startup, especially if you're young, if you're not in that kind of mature phase of your business, I mean, you have lots of money but not time. And I think Gradient and OpenAI, they cost and I don't want to get too into it, but they probably even cost less than it would to self-host some of these options, but they give you so much time. I mean, like, you can see how straightforward it was to set up everything in the notebook today. And that, it took no time at all. And the cost wasn't insane. I mean, we didn't do like a real full example or anything, but the idea is this tool buys you time, and time is so precious, right? If you can release your feature, your product tomorrow, or spend 6 weeks developing a way to release it, tomorrow, I mean, you're 6 weeks behind the curve. And companies like Gradient and like OpenAI are incentivized to have the kind of best of the best available at all times in order to differentiate themselves, which means you can generally rely on them having the best of the best for you. And if you can build with the best tools today, then you shouldn't spend time when you're in the early days spinning your wheels waiting for something that lets you build a product, right? Unless, as Mark said, you're looking to build a service that hosts, fine-tune, and makes available models.
But alas, everybody does want to know all of the details of exactly what's going on. So we struggle with this, and many of you learners out there know exactly what we're talking about. But I love Mark's comment on everybody I ever know that actually did it from scratch. They're like, I don't want to do this again. And I think that's, if you do it once. How about that? There's an answer. Last question. the question is there a concept of an infinite RAG real-time loop? And to color this a little bit, I believe this is the same person that asked the question. Imagine users can upload PDFs in real time and do RAG. My problem is when we scale this as users can upload up to 1,000 PDFs in real time, how does that actually work? Mark, do you have any thoughts on this? This is sort of a tough engineering scale question.
Yeah. I mean, in a way, it's similar to how streaming made its way into like analytics. Many of the high level concept is sort of how do you take in and update your indexes at real time, and also update embeddings and have the model possibly fine-tuned at an incremental basis. There is a concept of that, but I have not found anyone who's done it well or like where it scales quite yet. I think we're kind of in the beginnings of even scaling like simple RAG. I don't know if you've ever tried to like do RAG on top of really high scale data, but there are entire companies that are made to develop like, you know, hybrid search, right? That are trying to do both the keyword-based search on the documents combined with a re-ranker using embeddings. And that indexing aspect is pretty tough. And then throw the LLM into the loop too, right? Like to really make it infinite, you would want the RAG to happen at different nodes. So like whether or not the LLM needs to go in and make a decision and then decide to do the RAG again over like a different set of subtrees of documents. So, you know, you're getting me excited about this problem. I hope you're trying to solve it, because that's something that I totally want to dig into and kind of support, like, you know, the picks and shovels to do that, right? Like make LLMs faster, make them better, make fine tuning easier on them, and making the embeddings more available. I totally think that my hope is that's where we're going at one point.
The picks and shovels to do that. I love that. Reach out to Mark directly, question asker. Chris, take us home. What do you think on this one? Infinite RAG.
Yeah, it's definitely possible. It's just not it's not currently feasible, right? It's like you know, every one of these questions is like, of course you can do it. I mean, it's when you get to scale and when you get to these more significant engineering problems that you know, you face the problem that everyone else faces. I think the thing I would say to the question asker is, if you want to solve this, you know, you can do the classic startup task, which is think about scale later, right? I mean, this system is should be relatively straightforward to build, where you're able to have people uploading all in real time, the RAG being done in real time, even triggering fine tuning, you know, depending on whatever criteria you want to use, and then worry about scale later, right? The crux of it is that, as Mark said, this is a unsolved problem right now. We need people to try to start building it, though, in order to motivate it to become a solved problem. So very cool, technically possible, just maybe not feasible currently.
Yeah, awesome. Well, thanks, Chris. And thanks so much, Mark, for answering these super technical questions and helping our learners really understand and grok these tough concepts sometimes. We can't wait for the next event that Gradient and AI Makerspace do together. It's time to wrap this one up for now. All right, so thank you, everyone, for your participation. This brings us to the end of today's event, brought to you by AI Makerspace and Gradient. If this session resonated with you, you can definitely keep learning with us by applying for our upcoming Cohort 3 of LLM Ops in production, where you'll learn how to build, deploy, and scale all things production RAG applications, from mild to wild, from open source to closed source, from evaluation to improvement, and from LangChain to Llama Index. You'll also learn agents, build a production grade project, and present for demo day. Lastly, please share any feedback that you have on today's event that might help us bring more value to you in the future by filling out the form we'll drop right in YouTube right now. We look forward to hearing back from you, what you want to see from us in the future. And until next time, keep building, shipping, and sharing. And we will definitely do the same. Bye, everybody.